All right, guys, this question is going to go over 2022 question number 4. So this is a 4-parter, and these is a classic table question. So let's go through the parts. Part A, we are going to approximate r double prime of 8.5 using the average rate of change of r prime over our interval and show the computations to get our answers. Now, 8.5 is located between 7 and 10 here. So these are the values that I would want to use in this situation when we are trying to compute that average rate of change. So let me erase that and let's go ahead and look at my work. So the first thing is I note that that's going to be equal to this form right here. So this can be, you don't necessarily have to write what I have pointed here first. If you just simply went straight to plugging in negative 3.8 minus negative 4.4 over 10 minus 7, that could have earned you point number 1. So this right here can actually take care of it both ways. I didn't simplify this. I believe the scoring rubric, let me just go ahead and scroll over. The simplified answer was 0.2. So if you got 0.2, good for you, but you didn't need to. The second point was strictly because of units, and that's because at the end it says and indicate units of measure. Since we're talking about a rate, it's centimeters per day, which I wrote as centimeters per day squared. So I'll go ahead and scroll over here. You can pause if you want to read over the scoring notes, but those are your first 2 points for part A. Okay. Now let's look at part B. Part B is there a time t between 0 and 3 for which r prime of t equals negative 6 to justify your answer? Now, oftentimes when you're given r prime, the first thing I'm thinking about here is actually the mean value theorem. Now, the reason why I am not using the mean value theorem is because I would need to then know things about r double prime, or I'm sorry, I would need to know things about r of t. And then I would use the average change of r of t to then figure out, or not average change, the average rate of r of t, I should say, and compare that to r prime. But we were only given values of r prime. So to me, this is going to be an intermediate value theorem. And notice at 0, I'll go ahead and circle this here if my pen will let me. At 0, you'll see that we have negative 6.1, which is less than negative 6. And then at 3, we have something that's bigger. So that's already right there, 2 criteria. And then the other criteria here is that this is a twice differentiable function. These are going to be conditions that we need to use for IVT. So let's talk about what we need to do to answer and get all the points for this. I have a lot of arrows here, so I want to point out here how this works. So point number 3 says, and I'll use the language from the scoring rubric, says that you are indicating that negative 6 is bounded between r prime of 0 and r prime of 3. Now, however you accomplish that is up to you and your work. I wrote since r prime is equal to negative 6 r prime of 0 is equal to negative 6.1, which is less than negative 6, and r prime of 3 is equal to negative 5.0, which is greater than negative 6, that checks those 2 boxes for IVT. Now the other box that's really, really important here is this first one. Since r is twice differentiable, both r and r prime are continuous. Now this r right here is not necessary, but you do need to specifically state that r prime is continuous. And I want you to see here right there. So r of t is twice differentiable, which implies that r of t is continuous. That is going to be the second point here using the conclusion. And you can actually see down here to earn the second point, the response must state that r of t is continuous because r of t is differentiable. So at minimum, you have to be able to state r of t. R prime. If you do not state r prime is continuous, that will not earn that second point. So again, go ahead and pause to read over the scoring notes if you'd like to see that. Okay. And that is going to be your 2 points. So you have to state it's continuous, r prime, state it's below, state it's above, and therefore then make your conclusion that it does indeed exist. All right, let's go on to part C. Part C is going to use a right Riemann sum with 4 subintervals to approximate this integral. So you would have, again, interval from 0 to 3, from 3 to 7, 7 to 10, and then 10 to 12. Classic table Riemann sum questions where, by the way, the delta x value is different here. It goes from 3 to 4 to 3, and then to 2. So you will see here for this one is about the least amount of work you need here. At minimum, if you just simply write what I have here, you would earn both points 5 and 6. 5 for the right Riemann sum form, and then 6 for the answer, because this answer need not be simplified any more than you see here. And so you will see here, form of the right Riemann sum and answers, and then just as note here, there's that, what I said. That note right there owns both the first and the second point in this situation. You do not need to get the negative 51 answer here. No need to do arithmetic. All right, part D, last part here. This is talking about the height of a cone is decreasing at a rate of 2 centimeters per day. This is a related rate question. Now, what's really important here is times we've done cone questions, the cone has either a constant radius or a constant height, or there is a proportional relationship between the radius and the height. The thing here is they're trying to ask us to find, or they gave us dH dt. So that is right here. The height decreases at 2 centimeters per second. And as you can note up here, r prime is the change in the radius. And notice that that is given here, and we're analyzing this at t equals 3. So I think the biggest mistake in this problem when I'm listing out all of my initial conditions here is noticing that this right here, that dr dt, is actually from the table up above, and we're getting that negative 5 simply because we're analyzing the cone at t equals 3. So we have a lot of information here. We have dH dt, which was given, dr dt from the table, t, r, and h were all given in question D's wording. So you have the volume formula, which was provided as you noted, and then you have to take the derivative. Now I want to note here what this is saying. Point 8 is utilizing the chain rule. The chain rule meaning that when you take the derivative of each of these parts, because you have to use the product rule to earn 0.7 by the way, that you apply the dH dt and the dr dt appropriately to this problem. So when you do that, you will get your chain rule point for 8, and then being able to actually take the derivative using the product rule, you're going to get yourself point number 7. On that note, to get the last point, all you then have to do is take all of this stuff and just plug it in. And because this is non-calculator, I am just going to leave it exactly the way that you see it here. And just for safety measures, I'm going to throw on my units here of centimeters cubed per day, although the rubric does not score that. So if you did not write that, you would be okay. So here is that scoring rubric again. And notice they got an answer that, again, I don't expect you to get. But what's really, really important here, and there's a lot of scoring notes for this question, but if you had applied, and I need to go find it, if you had applied here, if you had made the error in assuming that there is a functional relationship between r and h, which we see in a lot of classic right cone questions, that you would only earn the chain rule point. So you would only get a 1 out of 3 for this. And that's a little challenging here because, again, oftentimes cone questions will have that proportional relationship, but that doesn't have it here based on the information that the conical shape, the radius, is changing at a different rate than the height. So it's not a solid cone in this case, being that it's an ice sculpture. Okay, that is scoring notes there. Feel free to look through any of the other questions that you have here, and that's all I have for you.